This is Unit 3, Matter, Part 2 notes. At the end of the unit, you should be able to investigate and classify matter into pure substances and mixtures. You should also be able to differentiate between elements and compounds and homogeneous and heterogeneous mixtures. You should also be able to use properties of matter to determine if a sample is a pure substance or a mixture. So recall that matter is defined as anything that has mass and takes up space. So matter can further be classified into either pure substances, or mixtures. If it is a pure substance, these are either considered an element or a compound. Element is any element that can be located on the periodic table. So if you can look at a periodic table, especially the one that's in your ISN, if you can look at it and find only one single element, it is classified as that element. However, if you look at an example and it has two or more elements, that is considered a compound. So if you would look at the examples on the left side of the page here, mercury is element Hg. It's one element, two letters, but that represents a single element that I can locate on the periodic table. Then if you were to look at the example below it where it has mercury sulfide, that is considered HGS. I have two elements chemically combined to make a compound. So the elements and the compounds are going to be periodic table, are going to be examples that you can locate using the periodic table. If you combine two or more substances together, so mixtures are two or more substances, you have created a mixture. So I can take two compounds, such as salts, and I can put salt into water to make salt water. That would be considered a mixture because I have two compounds physically combined together. Mixtures are further broken down to either being homogeneous or heterogeneous. Homogeneous is uniform throughout the entire substance or throughout the entire example. It's also known as a solution. And if you are to look at the examples on the right, we either have stainless steel or we have granite. The stainless steel would be considered the homogeneous mixture because you cannot tell the difference between the different steel molecules. As compared to granite here, I can see different colors, I can see different specs. That is a non-uniform mixture, hence it is considered heterogeneous. So as I said before, matter can be either broken down into either pure substances or mixtures. Pure substances are then identified as either a compound or an element. So these are just like the definitions of the different classifications of matter, where compounds are a substance that contains two or more elements chemically combined in a fixed ratio. When it says fixed ratio, I mean in salt NaCl, there is 1 sodium to 1 chlorine. You can also use water, H2O, where 2 hydrogens with 1 oxygen. These are fixed ratios, and they make up compounds because they are two or more elements. These can chemically be broken down. So if I were to break down NaCl, I can decompose them into chlorine and sodium elements. However, elements are the simplest form of matter that has a unique set of properties. You cannot break down elements. So if I have sodium here, you cannot break sodium down to anything smaller unless you break it on an absolute molecular level down to the protons, neutrons, and electrons. But in terms of classifying matter, you cannot break elements into something smaller. So again, any elements that can be located on the periodic table, that is an element. If you have two or more chemically combined elements together, that makes up a compound. So then mixtures, these are a physical blend of two or more compounds. And these are further broken down into either being a homogeneous mixture or a heterogeneous mixture. A homogeneous mixture is a mixture in which the composition is uniform throughout. These are also known as solutions. So if you look at this example of olive oil at the bottom, you cannot tell the difference between one side or one area of this liquid. It is consistent throughout. There's no extra pieces. There's nothing not dissolved in there. It is consistently the same throughout the entire container. Also, salt water. If you were to put salt into water or distilled water, water that's clear, the salt dissolves in the water, so you wouldn't end up seeing the salt anymore. It'd be dissolved, so it would look transparent. So anything that's transparent or they mix well together, that's known as a solution. And solutions can be identified by only having one phase. And the phase just describes the different areas of that container. So I have one liquid, that's one phase. As compared to a heterogeneous mixture, it's a mixture in which the composition is not uniform throughout. So for example, chicken noodle soup, or even ice water, and that is a typo here. It should not say salt water. Salt water is a solution. So if you say water with ice, in a cup of water, you have different ice cubes. Obviously, it's not the same throughout because you can cut that in halves or in quarters or look at it in different angles and it's not the same throughout. So scratch out that salt and please put ice water because that is a heterogeneous mixture. Heterogeneous mixtures can also be defined by having two distinct phases. So if I were to put the olive oil here with, let's say, water, you have two distinct phases because they do not mix well together. So having more than one phase in your container would automatically lead you to a heterogeneous mixture. And if you look on the sides here, it shows what they look like on a molecular level, so please take note of those. So recall that pure substances can only be chemically broken down. So you can only break down the compounds back into elements. So you have to use some sort of chemical means to separate that side of the classification of matter flowchart. However, mixtures can be physically separated because, as the previous slide stated, they are a physical blend of two or more compounds. So we can separate mixtures by using physical means based on their physical properties. So there's two examples here, as there's a lot more, but the two main ones that you'll see constantly throughout chemistry is a filtration method, where you're separating a solid from a liquid in a heterogeneous mixture. So for any people in here that make coffee, you put coffee grinds on a coffee filter and then you pour water through it, or whenever the water heats up, it goes through the coffee filter, it absorbs the caffeine, and then we put it into our coffee cups and drink it because it makes us happy. Well, filtration separates that solid from a liquid, so it allows the liquid to flow through while keeping the solid on the top, because I don't like to drink coffee grinds. Those are gross. So we use this method called filtration. And again, it requires some sort of filter paper that has small pores enough to let the liquid flow through while keeping the solid on top of that filtration. Another process is known as distillation, where you can separate components in a homogeneous mixture by boiling a liquid into vapor and then condensing it, that's a phase change, back into another container. So let's say we have a mixture of two different liquids and they have two different boiling points. Well, I can heat it up to the boiling point of one of those liquids and it'll evaporate, and then once it is trapped in this condenser, we'll cool it down. So we'll lower the temperature and it'll condense back into a liquid where we can separate the second one from the first one. So again, distillation is used to separate two or more liquids that are a homogeneous mixture. We'll heat it up enough to boil off one of the liquids. It'll flow through this condenser. We'll trap it in a different container, and then we'll have the liquids completely separated based on their boiling points. You can also separate different metals based on magnetism, because some metals are magnetic and other ones are not. So if you have a mixture of different metals together, I would probably utilize their magnetic property to separate those metals out. So what you should do is write down the following examples and then try to see if you can identify the following as an element, a compound, a homogeneous mixture, or a heterogeneous mixture. And just to review our matter classification chart, we'll either have matter separated into a pure substance or a mixture. So then pure substances are either elements or they are compounds. Mixtures can either be homo, which is the same throughout, or hetero, which is non-uniform throughout. So if you think about a tossed salad, well, I know it's not an element or a compound because I cannot locate them on the periodic table. And if you think about a tossed salad being a mix of lettuce, tomatoes, onions, croutons, salad dressing, hopefully you come to the realization that it's a mixture of more than one thing. And it's also considered non-uniform throughout, so that would be a heterogeneous mixture because you cannot have the same composition of tomatoes and lettuce and dressing on throughout the entire container. Nitrogen gas. So nitrogen is an element on the periodic table. It exists as a diatomic substance because it has two of itself. Regardless if there's a 2 or not, there's one letter that's N. You can find the N on the periodic table, which would make it a single element because it's not 2 or more elements combined together. It's 2 or more nitrogen elements combined together, but that is still considered an element because it's one type of element. So sodium chloride, table salt, NaCl, there is one element, there's 2 elements, so this guy is a compound. Sweet tea without ice would just be a container of liquid. If there's no ice and the sugar has dissolved in the iced tea, that is a mixture of sugar and water, so it'd be a homogeneous mixture because sugar is a compound and water is a compound. So 2 or more substances make up a mixture. It looks the same throughout, so it is homo. And then barium fluoride, where you have BaF2, there's one element, there's my second element, so this would be a compound. Cooking oil. Well, oil is not on the periodic table, so it cannot be an element or a compound, so it is considered a mixture because it's a mixture of different ingredients. And cooking oil looks the same throughout, so it would be considered a homogeneous mixture. Pecan ice cream. Well, I know pecan is one substance, ice cream is another one, so hence it is a mixture, and the pecans inside the ice cream would make it hetero because it probably doesn't have an equal distribution of pecans within the ice cream. So it's a heterogeneous mixture. Oxygen is another diatomic element. Oxygen's on the periodic table. It's one element by itself, even though there's 2 of them, but oxygen itself is considered an element. Sugar, C6H12O6, like glucose. There's 1, 2, 3 elements, a CH and an O, so that would be a compound. It is only a pure substance, one type of pure substance. And then calcium sulfide, CaS. Calcium is one element, sulfur is another element, chemically combine to make a compound. So have you accomplished the objectives? Are you able to investigate and classify matter into pure substances and mixtures? Are you able to differentiate between elements and compounds? Can you tell the difference between a homogeneous and a heterogeneous mixture? And are you able to use the properties of matter to determine if a sample is a pure substance or a mixture? So overall, if you know the classification chart and you can identify examples of each both on and off the molecular level, then you should be okay with this unit. If not, you should restart it, go back, or write down questions that you may have for me the next class period that I see you.